All right, what we're going to look at right now are some operations with functions. We're going to learn about adding, subtracting, and multiplying functions, and then we're going to look at an operation which is more specific to functions called composition. All right, so for these first few examples, we're given some functions, f of x, which is negative 3x plus 8, g of x, which is 9x minus 5, and h of x, which is 2x squared plus 4x minus 7, and lastly, we also have a k of x, which is 2x plus 3. So we're asked here to find a few things. F of x plus g of x is number 1. So let's start there. This means I'm going to add the two functions f and g. So f and g. I'm going to set this up. This is really what I'm doing here is substitution, and whenever I substitute, I should use parentheses. So f is negative 3x plus 8, and g is 9x minus 5. So when I go to add these together, I'm just adding this expression to this expression. These parentheses don't do anything really, so you can just take them off, or if you feel comfortable, you can go ahead and look at combining your like terms. So then, what do we get when we combine these? Well, negative 3x and 9x are like terms. Those two together will give me 6x. 8 minus 5 will give me plus 3. All right, so that's what I get for f of x plus g of x. F of x plus g of x, the sum of these two functions gives me this new function whose rule is 6x plus 3. What if I changed this and made it subtraction? Now again, I stressed the parentheses. You really have to use them here. If you don't, in all likelihood, you're not going to get the right answer, because the parentheses actually do something for this problem. Nothing's happening here. I can just take these off. But if I'm subtracting 9x minus 5, we would often call this, we're distributing this negative to the two terms over here. So I'm going to subtract 9x and I'm going to subtract negative 5, which means I will have minus 9x. And if I subtract a negative, that means I'll really add 5. So make sure you're distributing that negative. Minus negative 5 means plus 5. Okay. Now again, as in the previous example, I'll look to combine my like terms. Negative 3x and negative 9x is negative 12x. And plus 8 and plus 5 is plus 13. And I can continue doing on like this. Most of these operations are relatively simple until we get to something like number 5 where we have to multiply. Let's go ahead and look at this next example right here, f of x plus h of x. So f of x is negative 3x plus 8. And h of x right there is 2x squared plus 4x minus 7. All right, so what I need to do here then, I can remove the parentheses, and I will look to combine my like terms. Now notice here I have 2x squared. I have a squared term, or what we'll call later a quadratic term. This does not have any like terms among the other. That's an 8. Sorry, my pen slipped. Negative 3x is like to 4x, and 8 is like to negative 7. But 2x squared does not have a like term. So what I can say then is f of x plus h of x is 2x squared plus x plus 1. Okay. So, do one more like this. If you want to go ahead, we'll start this off. You can pause the video and try this yourself. K of x minus g of x. So k of x is 2x plus 3. And g of x is 9x minus 5. Now, if you didn't pause already and you want to try this, now would also be a good time to pause. I'm going to go ahead and proceed. Again, I'm subtracting this, so I have to distribute that negative and say 2x plus 3 minus 9x plus 5. which is going to give me negative 7x plus 8. Okay. All of these examples just involved adding and subtracting two functions. What if I wanted to multiply two functions? F of x times k of x is negative 3x plus 8 times 2x plus 3. So in order to do this, I'm going to need to multiply these two binomials. Now you can multiply two binomials. There are several methods. FOIL is a very common method. Another commonly shown method is to multiply using a little box, wherein I would put my binomials alongside the box and multiply inside here, like 3x and negative 2x would go here, and that would be 3x times, or negative 3x times 3, and so on. We'll talk more about these as we move through the year. The one that I'm going to use primarily, and that I'll show you today, since I'm multiplying negative 3x plus 8 by 2x plus 3, that means negative 3x has to get multiplied by 2x plus 3, and plus 8 has to get multiplied by 2x plus 3. So I'll kind of split this up and distribute twice. What do I get when I do this? Well, I'm going to have to distribute. First up, when I multiply negative 3x and 2x, negative 3 times 2 is, of course, negative 6. Recall, x times x. By definition, if I multiply a variable by itself, that means I'm squaring it. So x times x gives me x squared. When I distribute negative 3x to 3, I have minus 9x. Down here, I will have plus 16x plus 24. I can now combine my like terms, and what I get is this. All right. So those are some basic operations with functions. The next thing we want to look at, the big thing I want to take away from this, is composition of functions. So, if I were to do composition of functions, well, let's lay the groundwork a bit. If I give you a function f of x equals negative 2x plus 9, and I ask you to find f of negative 5, that means this negative 5 will be substituted for x. So I'll write this, and I'll get ready to substitute. And if I put negative 5 in here, I can go ahead and simplify this. Negative 2 times negative 5 is 10, and 10 plus 9 is 19. So this is something we've already discussed. Did in Algebra 1, shouldn't be too big a deal. What if I instead asked you to find f of 3x plus 7? Over here, I knew that this negative 5 took the place of x. Here, the same thing is being communicated. 3x plus 7 will substitute for x. That's how we'll approach this problem. So if I do that, what will I get? Well, again, I'm going to start this off. I'm being very deliberate here. I'm going to substitute into f. So I've written out some open parentheses. What's going in? Well, 3x plus 7 is what's going in. And now I'm left to simplify the expression on the right-hand side. So I get that f of 3x plus 7 is negative 6x minus 5. This idea right here is composition of functions. The composition of functions substitutes a function, or in some cases its output, into another function. Now, here I wrote it a bit differently from how it will normally be written. This is the way it's commonly written. Commonly, you will see this, for which we will say f of g of x. What is it asking me to do? If I see this, sometimes it'll help me if I take a pen and just trace it over. Those are my outermost parentheses. Whatever's in here goes in place of x. So that means g is going to replace x. G goes into f. So I'll set myself up to do some substitution. And in place of x, I put g, which is right here, negative 3x plus 5. So if I do this, when I multiply, I will have negative 12x plus 20 minus 14. I can combine my like terms, the 20 and the negative 14, to say that f of g of x is equal to negative 12x plus 6. That's the general idea. This can only be made more complicated by including more advanced functions and things like exponents and stuff like that. But this is the general idea. Now here I did f of g of x. G went into f. Here I have g of f of x. F goes into g. What's going to happen here is I'm going to get an answer that might look kind of similar but will be different, because changing the order of these generally gives you a different result. What am I putting into g? I'm putting in f of x, which is 4x minus 14. This gives me negative 12x. Negative 3 distributed to negative 14 is going to give me plus 42. And I will get that g of f of x is equal to negative 12x plus 47. That's really all that's going on with this. 4 and 5 down here are essentially the same idea. 3 and 6, those look a little bit different. Notice, here I had f of g of x, I had g of f of x. Here I have f of h of 4. So if I'm thinking the same way I did in the previous problems, what am I putting into f? Well, into f, I'm putting h of 4. And in order to do that, I first need to know what h of 4 is. Well, h is 1/2 of x plus 3. And I'm putting 4 in place of x. So this will give me 2 plus 3, which is 5. So h of 4, which is 5, is going to be put into f. What I really need to do to solve this problem is to put 5 into f. So 4 times 5 is 20. 20 minus 14 is 6. And that's the answer I should get for that problem. Let's do another one like that. All right. If I said g of f of 6, here, f of 6 is going to go into g. So I'll do this in 2 steps. I'll find f of 6, and I will take that result and put it into g. So first off, for f of 6, if I want to substitute into f, I start off like this. 4 times 6 is 24. 24 minus 14 is 10. I'm going to take that 10 and put it into g. In place of the x, I will put 10. So I have negative 30 plus 5. Which is negative 25. I'll leave these examples. They'll be on the answer key. All right. So that is most of what we need to know about composition. Some more examples we're going to go through here. I alluded to this a minute ago. In this next example, I'm going to have a square, and then we're going to look at a couple other ways I can do composition before we wrap up. So here, I'm given that f of x is x minus 4, and g of x is x squared plus 5. We're asked to find g of f of x. So if I want to substitute something into g, I replace x with whatever I'm putting in. Now notice, x is squared, so whatever I put in is going to get squared. Very important. All right, what am I putting in? I'm putting in f of x. So what I will get here is x minus 4 squared plus 5. Now before you make a mistake, that's very common, x minus 4 squared, in order to actually square that, I cannot do anything like taking this and just squaring the x and the 4. That's not how this works. If I think back to the problem we did a few minutes ago, and I'll write some work off to the side here, x minus 4 squared means x minus 4 times x minus 4. This is what it means to square something. So I would have to FOIL, use the box, do something else, whatever. I will show you, again, splitting up this term and multiplying it to the second binomial. If we do this, x times x is x squared, minus 4x, minus 4x, plus 16 is x squared minus 8x plus 16. So that all is x minus 4 squared. I'm just going to mark this off to try and keep my paper a bit neater. So what do I have now? I can replace x minus 4 squared with x squared minus 8x plus 16. And I still have this plus 5. So I will get that g of f of x is x squared minus 8x plus 21. All right. There's a part B here where I'm asked to find f of g of 1. Again, I think about what this is telling me. G of negative 1 is going to go into f. So what's g of negative 1? Negative 1 squared is 1. 1 plus 5 is 6. So then what I'm really finding, f of g of negative 1 is really f of 6. which is simply 2. All right, almost done. There are two other ways I can look at composition. Doing it algebraically and doing this sort of twist on that where I plug a number into one function and plug that result into the outer function. These are very important. Also worth knowing, we can do composition if functions are given with graphs or tables. So I want to find each of the following using the two functions graphed at right. I have this curve, a parabola, which is f of x, and I have this line, which is g of x. And what I want to find is what is f of g of 6. Just as before, I will start this off by finding g of 6. How do I do that with a graph? Well, recall this is x. When x is 6, I have this point right here, 6, 0. This x is paired with this y, which means that g of 6 equals this y value, 0. If g of 6 is equal to 0, then what I'm really being asked to find here is f of 0. So again, I will take the x value and go to my function. Be careful here, there are two different functions. When x is 0, I want to go to f, which is the curve. And I see this point down here, 0, negative 5. Which is then my answer. All right. Explain one or two more of these. It takes a minute to get the hang of this. F of negative 1. Again, f of negative 1, this is my x value. So I start off with, I go to where x is negative 1, and I go to f, which is this curve right here. And it looks like I'll be right down here at negative 2. So g of f of negative 1 is really g of negative 2. Just as before, I find the output and put that output into g. When when x is negative 2, g looks to be up here at 4. If you want to go ahead and take a look at the next one, you can pause the video, g of f of 4, see if you can figure it out from the graph. I'll go ahead and do the last problem too. G of negative 2. I have a function, I have a composition of a function with itself here, which is something that can happen, although we did not do an algebraic example of that. G of negative 2. G of negative 2 we found a few minutes ago is 4. So then what I'm really finding, I take that 4 and I put it into this g. G of 4 looks to be 1. The composition of this, I can't say you'll see it a lot, but certainly understanding this way of evaluating a function from a graph, That is an understanding we definitely do want to possess. Let's look at one more problem type. If I want to do composition using the table, I see here a chart. One column has x's, one column is labeled h of x, another column is labeled k of x. So for each of these inputs here, I can tell the value of h and the value of k. So for example, this right here signifies that h of 7 is equal to -2. How could I use this information for composition? The same way we have been doing. I work from the inside and go out. I want to figure out what k of -2 is, so I can put that into h. K of -2, when x is -2, k is 7. And so I want to know what h of 7 is. When x is 7, h is -2. And I can keep doing this for my other examples right here. For k of h of -2, I have to figure out what h of -2 is so I can put it into k. H of -2 is 0. K of 0 is 5. Excuse me, I made a mistake. That's h of 0. K of 0 is 3. Be careful there. Easy mistake to make. Obviously, I just did it. Don't do that. Be careful. H of k of 7. Again, start with the inside. If you want to do this yourself, go ahead and pause. K of 7 is 3. H of 3 is 4. So that gives you an idea of how you would use a table to do composition. Hopefully this has made sense. Remember to ask questions if you need help, and make sure to study hard and do your assignment.